start that, I also wanted to highlight few of the impact numbers and the work that has been happening out around the country. When we say India AI Impact Summit, we all might be thinking out this is another program, another event that has been happening out. But it's more than any kind of action. It's more of an kind of impact. While we are looking out for the numbers and the quality, we all have seen that the Stanford Global AI Report already have cited India is number 3rd vibrant ecosystem in the world. As well as if you look out to the GitHub repository as of now, India hosts one of the 2nd largest repository in the AI project side. And this is the quality that India is bringing out. But this is also backed by the investment side. In the last 1 decade from 2013 to 2024, we have raised somewhere around 11 billion plus fund in the dollar world. And that has came from the report which has generated by University of Stanford. And also if you look out to the Google, that has made almost $15 billion investment in the last 1 year, which is one of the biggest to date, till date over here. And Tata also have declared almost $11 billion fund to the India. And this fund, when you look out, is actually a strength for which India is driving out into the AI sector. We have a stellar panel coming out from the research community, coming out from the international community as well. And this panel will be having a lot of insightful discussion, lot of insightful keywords which will shape the AI and also the policies which will come in the coming days. I'm very much thankful to all the panelists over here, including Dr. Ajay, Professor of Chemical and Biology Engineering from the University of Saskatchewan. Also, we have Dr. Devi Prasad, from Senior Principal Scientist from CSIR, IMT Bhubaneswar. We also have Professor Rajiv Ahuja, Director at IIT Roper, who will also be giving out key insight on this particular topic. We as well have Dr. Manisha V. Ramesh, Pro Vice Chancellor at Amrita Viswa Vidyapeetham. We also have Dr. Mukesh Saini, the Principal Investigator at Annam.ai, which is an initiative from Ministry of Education, and also faculty at IIT Roper. Along with that, we have Dr. Santosh, who will be giving out key insight on the work that they are doing out. With that, I open this particular panel for the discussion, and first I would like to call Dr. Rajiv Ahuja, Director at IIT Roper, to give us key insight on the work IIT Roper is driving out, specifically in terms of the AI, in terms of the agriculture, which is one of the foundation for the entire humanity. With that, I would like to call Professor Ahuja.
So thank you, Mukesh. So welcome to all of you actually, and somehow we got very small lecture room actually. Maybe Canada is too small or it's too big, because I don't know actually. If you compare the Canada by area, is very big, is bigger than India. So but we got very small hall, so we should not complain about that. So we welcome all of you here at this special session. This is basically a 55-minute session, and what we are doing in this one is because we want to use AI for different application, and this is aligned with the Ministry of Education, where they have decided 3 verticals in under AI mission. One is agriculture, healthcare, and the smart cities. And you can see that 2 of them you are going to cover directly, and energy indirectly, because for smart cities we need a good energy resources also. So this is a very broad in the topic side. And what IIT Ropar is part of this one, because IIT Ropar is hosting or having this AI COE for Agritech. And when we talk about innovation, when we talk about startups, but if you look at number of startups coming up from IIT Ropar, especially in Agri-Tech sector, I would like to say that 30% deep tech startup of India is coming from IIT Ropar when it's come to the agriculture. So we are a full-fledged IITs, and Agri is one of the vertical actually we are working it. And I'm sure that this kind of a panel discussion gives us opportunity what the best practice they are using in Canada also, and how we can work with the Canada, especially we have people from University of Saskatchewan, and Saskatchewan is a province is known for agriculture, and there many of Indians are settled in Saskatchewan in province actually. So I have even a possibility to meet your minister also from Saskatchewan. So this is a win-win opportunity for both sides, and we can use the best practices of India, and we can use best practices of Canada, and we can start with this meeting a new kind of collaboration between Canada and India, especially with Saskatchewan or other agriculture universities in agriculture, or universities working in health science, to start this collaboration with Indian institution, not only with IIT Ropar, but IIT. So this is our vision for this symposium, and I'm sure this next 50 minutes will be very engaging and very fruitful, and we will learn from each other. With that, I stop here. Thank you.
Thank you, Professor Oja. While India has already made a very impressive start, and India AI Impact Summit is also one of the kind of an impact-driven program that we are seeing. And last 2 days, we already have witnessed the progress we have made. But the next phase will demand very sharp and strategic collaboration, and this is one of the key program which we are doing with India and Canada. We already are hosting one more program with India Korea, which is happening in parallel. And just yesterday, we have hosted another program with Israel Embassy. And this collaboration will be kind of shaping out the entire policy and entire strategic relationship with that. Professor Rauja also have another event to attend in parallel, and therefore he might have to leave little early. We apologize for that part, but sir has to go for the Korea program, which is happening in parallel with Government of Punjab, just next to this particular hall. Yeah. With that, if you look out India AI mission since launch in April 2024, we already have seen 10,000 crore plus of fund which has been deployed by Government of India. And this is where also a lot of collaborative approach has came from the corporate and from the VC community, which we already have seen from the investment, like I said in the past, from the Google, from the Tata, and every other sector is putting out huge investment. Just before this, I was hearing out another session, which was hosted by Sri Amitabh Khan, a key figure into the entire startup research and to the government sector. He also have spoken about the work which MIT is doing and also had a lot of discussion. This is where I would like to call our next speaker, Dr. Ajay, professor of Chemical and Biological Engineering from University of Saskatchewan. We would like to know the work that he is doing and also how India and Canada could build the next AI policies for agriculture, for health, and for also in the energy sector. Welcome, sir.
Well, good evening. Thank you all for joining this particular event, and also wanted to thank our co-panelists in this particular session. Baljit Singh, who is the Vice President of Research, could not be here, who basically put it together with Professor Ahuja about this Indo-Canadian Symposium for an AI for food, energy, and health sector. So I work in the Chemical and Biological Engineering department, and just started working in this area. I also held a Canada Research Chair in Bioenergy for 24 years that just ended. So when you look at the Saskatchewan itself, it's you cannot really compare with any cities in India. Our province has only 13 lakhs of people, and it's probably as big as India. So every square mile we have only 2 people living. And so the average land holding, agricultural land holding is about 6,000 acres per farmer. And also we have about 48% of agricultural land in our own province. This particular province, as I mentioned, has only 13 lakhs of people, has also about 25% of world's uranium and 30% of world's potassium. And also it has too much oil and gas as well. It exports oil and gas to other places in United States as well as abroad. So when you look at the AI for food, energy, and health sector, we have a less number of people. So I think the strategy is there to help the farmers to maintain the productivity. So our province alone exports about 85% of chickpeas, green peas that Bangladesh requires every year. 85% of the country's peas come from our province. And our Prime Minister will be here in first week of March. We had a little bit of issue with India before, and I think it is getting rekilled out right now. Our Chief Minister, we call Premier, he will also be here in first week of March in India. I think the strategy is to work on the agriculture side, food, and also critical minerals, and One Health that we are working with India as well. So when you look at the AI, it's very, very important to look at the heterogeneity of biomass, for example, that once we take the crops, then we have a lot of residue in the forest sector, the agricultural sector. And the world produces about 200 billion tons of residue every year. So what happens to the residue? If you don't utilize them, they will also emit methane, which is a greenhouse gas. And so the utilization of various residues for hydrogen production, transportation, fuel production, aviation turbine fuel production, those are the issues or those are the focused research that we have. Canada targets to be net CO2 zero in 2050, and so there are a lot of policy in place, there are a lot of money in place, and we're looking at working with India, especially India is quite advanced in manufacturing and also the critical minerals area as well. Though we have a lot of minerals, but we don't have a lot of technology that can take this forward. So the Premier and the Prime Minister are here to see what we can do together. And also we have a shortage of people. As you know, we had 721,000 students 2 years ago. Last year, about 80% of Indian students could not get visa because we had issues. That has been wrinkled out as well. We had a meeting with our Canadian ambassador in New Delhi last November, and it's a new person. So I think things are getting better. So when you look at the complex issues that India and Canada face, the AI would be a core for solving the problem. Looking at the heterogeneity in the different biomass sector, and how do we produce hydrogen, how do we get the transportation fuel that we want to replace with the fossil fuel based transport the fuel. So there are a lot of things that we can do. We have just started working in this area, and we are here more to learn than to contribute. So I'm glad that you're all here through question and answer session, through our panelists and through you. I think will be very educational for us. And I'll meet with our Premier in 3rd of March, hopefully pass on some of the key outcomes from this to the team. Our VP Research, Baljit Singh from Punjab, is the second in command in university. It's a 115-year-old university with 27,000 students, 6,000 staff, and 1,400 faculty members. So he's the second in command. He'll be here tomorrow, and we'll also pass on the outcome to him and his team as well. So just wanted to stop here, and hopefully we'll have a very encouraging and effective discussion. Thank you so much for your attention.
Thank you, Dr. Ajay, for giving out brief work as well as the detail for India and Canada. I remember when Dr. Baljit Singh ji, the Vice President for this Vice President Research University of Saskatchewan, was building out this particular program. We had a lot of thought and a lot of discussion how basically two countries could collaborate. I come from Punjab, and we often say that Canada is another home for most of the people coming from Punjab. And that's where we now coming from the IIT Roper also would love to work collaboratively, would love to also build a lot of research work. Punjab also faces a lot of problem in terms of we call stubble burning, and that's where also I think a lot of synergies between two of the countries and two of the research institutes are there. Next, I would like to call our Professor Rajesh, Rajiv Ojai is not. Dr. Devi Prasad ji, Senior Principal Scientist at CSIR. He'll be giving brief work that CSI is doing, one of the India's premier institution, and the lab that works a lot of work from the research and innovation side.
Thank you for introducing. This is a great pleasure that I get a chance to speak before you with the India-Canada collaboration and joint programs. We are from a CSIR lab. CSIR stands for Council of Scientific and Industrial Research, which is established in 1942, pre-independence. And CSIR has got 38 labs in all domains. You talk of food technology, glass and ceramic, National Aerospace Laboratory, NPL in Delhi, road research, CRRI, IGIV. So like this in Odisha, we have a lab called Institute of Minerals and Materials Technology, Bhubaneswar. So we work mainly on mineral ores and minerals, and how to extract valuable minerals from the ores with sustainable approach. So we also apply a lot of AI techniques in those instrument making and design of new materials. So this way we are contributing to the AI to the country's development. So talking about the India-Canada collaboration, like Professor Dalai, he also basically from Odisha only. So we have a connect Canada and IMMT as a connect on working towards critical mineral exploration. Our institute is recognized by Ministry of Mines as a center of excellence of critical minerals. So we have a lot of institutes collaborating to contribute to the extraction of critical minerals in the country, so that that will be helpful in the future development of India, because all the EVs and other things, they require critical minerals, and there is a very high scarcity of critical minerals in the country. And to extract manually, it will take huge amount of time and resources. So application of AI/ML in all fields, starting from the mineral processing, mineral exploration, to the instrument design, to large language model applications, all these will help in quicker establishment of technologies. That is why CSR has also spent a lot of money in AI mission project, and we have AI mission project where most of the labs are working. So we are also running such type of projects in our country through different labs. In addition to this, CSR also contributes to the education of the country. There are 2-3 ways we are contributing. One of the ways, for the school children, we have a Jigyansa program. So we also educate school children about the advanced technology, including AI/ML techniques. We also provide PhD studies, PhD degrees, where people from after passing MSc with NET and get qualification and BTech, MTech qualifications, they can pursue PhD in India through our institute. So there is a CSIR degree they are getting. So like this, several ways India is contributing, and CSR is contributing to the growth of India. And we see a lot of opportunity of Canada, India through AI/ML applications in many fields. That is why I also welcome all of you. Anybody has got any interest for our collaborations, we are always open for that. There are different schemes. We collaborate with academics, we collaborate with startups. So we can have MOUs, and we can also have joint collaboration and development. Thank you very much.
When we talk about CSIR, I think most amount of research, innovation, and technology has been built by the public funded universities and the institutions. CSR has contributed immensely in this particular work, and we really feel proud to see the work which is happening at CSIR Bhubaneswar there. To the next, when you look out to India, I think we all have been saying out, we have a lot of bureaucratic hurdle, lot of deployment challenges, and this is where it's also very high time for us to develop and deploy at the right speed, at the right direction. I would like to call upon my next speaker, who have been doing out a lot of impactful work in terms of communities, in terms of bringing out this particular AI, LLM based models, and also the research work, not only to the field deployment, but also at the research community. I would like to call upon Dr. Manisha V. Ramesh. She is the Pro Vice Chancellor at Amrita Vishwa Vidyapeetham, and would love to hear your thoughts into it, ma'am.
Thank you, everybody. Thank you for inviting for this program, and it's indeed a very proud moment for India to have this big event on AI, which is happening, which is actually transforming the whole country. Amrita, I think Amrita Vishwa Vidyapeetham has been forefront in working on compassion-driven research. So AI and compassion combination, you can see at Amrita, where our Chancellor Amma is very focused on how global challenges can be solved through compassion-driven research. So one of the major aspects what we have learned is like, to alleviate poverty, you have to actually, one is you give food and shelter, but at the same time, you have to have love and compassion. If you are able to provide love and compassion, then the rest will happen naturally. So that is the approach Amrita University has used. And in this approach, we have brought in programs where students and faculty are able to live in the communities, understand the challenges, and then co-develop solutions in the communities, which is, the program name is called Live in Labs. So one of the major thing is like, how do you get what is a real challenge anywhere? So if you say AI for food, energy, and health sector, until and unless you don't know what is the real challenge, AI cannot help you. So how do you bring in that perspective from the community itself on how to understand? So we have built solutions where we were able to involve community use digital tools which will basically help them to map their own resources, understand the challenges based on that, and then it will benchmark with what is available in the world. And based on that, interventions, different pathways for interventions can be brought in. There is a unique digital platform called SRI has been brought up, which will actually look into it, all these different aspects, whether it is water. Water means each of the resources you have, what is the quality of the water, what is the quantity of the water, how many sanitation you have, how many toilets you have, all different, what is the disease prevalence in the community. So you connect, interlink all of these things and understand where are the challenges, because the challenges in the community never stand as separate as island. It's all interlinked, whether you take with respect to food, whether you take it with respect to health, etc. So it is very important when you build solutions, it actually looks into these interlinkages and bring out what is needed for it. So AI doesn't help by AI itself. There is also an intelligence which is coming from the human side, which is actually augmenting both of them together to build it. And what is happening, it is earlier we were working with individual competence. Now it is happening as a collaborative competence which is helping us to bring up with the solutions. So Amrita also worked a lot with respect to into healthcare aspect. In healthcare, as you know, that Amrita has 2 large campuses, with one in Faridabad with more than 2,600 bed hospital, and one in Kerala in Kochi with 1,400 bed hospital. But what makes us different is the university has 10 campuses with more than 40 schools with 35,000 students. So they are all connected in this interdisciplinary ecosystem. They work very collaboratively with the doctors. So they are working with them to understand how do you remotely monitor the patients, because if you look at the communities, they have a lot of diseases, but most of the time we doesn't even know that it exists. The community member doesn't even know. How do you make them even to understand that I have a challenge? Second thing is, if I have a challenge, at the same time I don't want to go to the hospital because I will lose my daily wage. So how are you going to build a solution which will real-time monitor, real-time you do the triaging and help them to take the decisions and the doctors to help them. So we have built a lot of remote monitoring systems and built a community resilience resource centers in 14 states, which connects to more than 200 communities, where they are able to have the tele-diagnosis and real-time monitoring to understand their health statistics. Along with that, we are also working largely on the malnutrition. So very large work which we are working into it to understand India has a large prevalence of malnutrition. we have over the years, all the faculty and students are able to work on with the community to take science to the field. Thank you.
Thank you, Dr. Manisa, and I think very rightly said, we need to talk more about the deployment of the technologies, bringing out something from lab to the field, and also how this research could actually impact. While we have seen that most of the research which come from the academia, highest number of patents, highest number of papers, all come from the academia, and we are number one in terms of the academic ecosystem in the world, with having more than 44,000 plus institutions and 1100 plus universities. India graduates almost 4 crore plus students every year. And this is also very high time for us to leverage this particular talent, this particular manpower for the right way. This is where we have another speaker who will be giving out his insight on the work which he has done, which already has been deployed. And like previous speaker already have said, it's more important for us not only to build AI LLM based solution, but also to deploy them in the industry. I would like to call upon Dr. Santosh, who will be talking about the kind of work which he is creating in the CSIR. And also I would like him to highlight the technology he has built on AI ML and how this particular technology has already been commercialized with the industry. Over to you, sir.
Thank you, sir. Good evening, everyone. So here I'll speak about how we converted small idea into successful product using AI techniques. Actually, we are basically from CSR IMMT Bhubaneswar. We developed two technology for steel industry using AI techniques, which is commercialized at JSW Steel Bellary and BMM Hospet, BMM Steel Hospet. Actually, what is this technology? Earlier days, steel industry used to measure pellet size by operator, seeing pellet growth manually. He will operate different parameters to control the pellet size. Pellet size depends generally speed, rotation of a disc, and feed rate, and water content. So generally they need pellet size 8 to 16 mm. Human measurement involves lot of error. So we developed using a camera-based technology. Initially, we used classical image processing to measure pellet size, but that involves a lot of measurement error. Afterwards, we introduced AI-based techniques, which is giving 96% accuracy, and we filed patent for this technology. We transfer technology to one Hyderabad-based company, which is commercialized at BMM Ispat, BMM Steel Hospet and JSW, competing with the foreign brand, and our technology is best compared with the foreign brand. Another technology we developed that is called export ion pellet, which will control the pellet size. First technology will measure the pellet size, that is the monitoring system. Second system is to control pellet size, that is range of 8 to 16 mm. Generally, simple PID control cannot work in that domain, because pellet size depends various parameters, very complex process, multiple input, multiple output system. So we developed AI-based expert control system, which will control the pellet size 8 to 16 mm. The industry needs generally more than 90 to 95% is size in the range of 8 to 16. Using our technology, the both steel industry, the JSW Steel and BMM Ispat is running their plant in auto mode. Earlier days that was operated by human operators. And we developed another technology also, that is the grinding mill, ball mill, how to know what is happening in the ball mill. What ball mill is the grinding mill, which will reduce the bigger size to finer one. So we don't know what is happening inside. Using through vibration technology and AI ML techniques, we can predict what is happening inside the ball mill. So these 2-3 technology already we commercialized, and this successful technology which is available in market. Thank you.
Thank you, Professor, for giving very technical work, which already has been commercialized. We already have seen the Indian models, be it Savam or be it Bhasini, already has been deployed at very high scale. The DPI which India is already building, be it Aadhaar or be it UPI, we have seen whatever product India have launched has already impacted 1 billion plus people. And that's where the LLM model also, if India work, will be able to impact not only 1 billion, but largely 8 billion population for the world. With that, we have next speaker coming from IT Roper, Dr. Mukesh Saini, who is working with Annam.ai, a very important project coming from Center of Excellence by Ministry of Education with almost 300 crore plus work. I would like again to have you here, sir, to speak about the work which we are creating at Annam, largely on the digital twin. That is what you are leading, and would love to hear your insight into it.
Thank you, Mukesh. Thank you, fellow panelists, and thank you all for your time. So at Annam.ai, we are addressing this problem of food from food availability perspective. Like when I see at food security or food sustainability problem, there can be multiple directions. First, we need to have food. Second, if the food is available, then there should be some traceability. I want to know what I'm eating. And third major dimension which we recently identified, and we experienced that earlier also, but something that AI could address was food adulteration. And that's happening a lot in India. A lot of people are doing that. So we have developed AI solutions for mainly for at Annam.ai, we focus on pre-harvest issues of farmers and crops. And we have one interesting solution for adulteration also that I'll discuss in the end. So at Annam.ai, we have three major goals. So it's a center of excellence with a very precise mission. So we are not allowed to like go here and there and just focus on a few things and convert them. So one thing is like we are building a few hardwares to capture data from the farm, from soil or from location. So for that we are building hardware. So when I say we are building hardware, we are not getting these prefabricated boards and assembling components. We design our PCB there and we assemble our components there in prototypes, and we make full custom boards there. So we make full hardware there. So that's our first task, and you could see in our stall we have this weather station and soil sensors, some sensors which are already scaled and which are available in the market. And second thing is farmer interface. So we have to give whatever knowledge we are getting from sensors and AI modules to the farmers. So we are leveraging this LLM in order to make a farmer-specific, India-specific, and some crop-specific LLMs which can answer farmers in their own language. So that's our second pillar. And the third one is we are exploiting whatever could be done with computer vision and images. So that's where I do a lot of work. So in image-based crop analysis and helping agricultures, we are focusing mainly on 4 problems. So first one is crop identification. Like we take an image and we identify what crop it is. Now there was a question by some audience that farmer already knows what crop it is. What would the farmer do with this information? Now if you take any crop advisory, any pest detection, any disease detection, any AI model you take, that model has to know what crop it is. And that, like, you don't give an input, this is wheat, you have to give some embedding. The model has to know in AI language what crop it is so that it can fine tune the solutions and provide very robust solutions. So that for that purpose we need crop identification. Even the advisory, it depends on the crop and its stage. What stage crop is it? So we are doing this crop identification. And again, for that also you will see there are a lot of groups who are building similar solutions. Our solution as of now is best in the world. It's 99.2% accuracy. Now when I say 99.2% accuracy, it doesn't have much weight, because I can take a Kaggle dataset and I can get the accuracy of 99.8. But our model is tested on 3 million images. So that covers almost entire, like we did field testing by 112 farmers across multiple states. On field, our model, it never failed. But we'll not say that it's 100%, because even in our data set, We have very challenging cases like very small rice and small wheat. They look very similar. So those cases they fail. So we have this 99.2 and it's deployed. Very soon we'll be using that for Ministry of Agriculture and Farmer Welfare. And the second thing is we are doing pest detection. So again, for pest detection also you will see a lot of solutions. Even there will be many stalls there. So we made a first pest detection solution. We presented that to many farmers and agriculture scientists. And they made a very funny joke, like a farmer came and they say we displayed with nice demo a pest image uploaded and we classify that into a pest. So the person says ki so you are taking this case such as pest will sit there, he will wait कि ये मेरा पेपराइज हो रहा है, मैं फोटो लेता हूँ, आराम से आप फोटो लीजिए पास में जाके उसकी, and then the pest will fly कि अभी मेरा फोटो हो गया है, तो it will go in some newspaper. So they said it never happens. Neither we have zoom cameras where we can take big pest photo. Pest is very tiny and it sits at the bottom of the plant or on a leaf. It's very small, so it's very difficult to even like if you give little closer, it will fly away. So we take random photos and it's a very small thing. So but for that we didn't have data. So we used advanced AI, generative AI these days. First we captured plants, we made 3D models, we made pest 3D models, and then we used this imprinting technique in order to create large amount of data. And because we are generating this, we made very small pests. Our model is able to detect in-field pests. So we have 25 pests, and for that our accuracy is 94%. And when we say pest detection, it's a very small tiny pest also that is being detected. Similarly, for disease detection, we have used these AI-based data augmentations, and our accuracy is 92%. Finally, there is very interesting requirement that came from many insurance companies, that they have to do crop surveys, and even the farmer, they have to understand the amount of damage that has happened in the farm. So we have developed a model that when you take a mobile image using a mobile, it will give an approximation of how many plants are there and how many of them are damaged, so that you can calculate the amount of damage that has happened. So we have quite good solutions for them, and I talked about 112 farmers. We are able to get very good ground level farmers, not I will not say progressive, but they are like working in the farm, and we give them skilling incentive and they give us data. So every day we are getting 15 to 20,000 images from the farms of pests and crops. Currently we have around 1.5 million images, but it's growing. Within a couple of crop cycles, we'll have a good Indian crop representation, and that will be made available in our DPI, probably in AI course, so that we solve all the problems of crop analysis using computer vision in Indian agriculture. Now I'll take 2-3 more minutes to discuss my food adulteration work. So when in India, all these powdery foods, people add cheaper things in order to increase their weight so that they can get more money. So we started with very challenging case. Turmeric, it's very difficult to identify, because even if you add some foreign body in turmeric, it's antiseptic. So it's not ruin, but it's not good for our health, for our stomach. So we want to eat turmeric, So we took turmeric, we tried taking images and tried to classify as long as there is a different color substance that is added. We can identify that, but those who are doing it, they are not that stupid. They make it look exactly like original turmeric. What we did some study, we discussed with chemical engineers and electrical engineers. We came up with that dielectric constant of a product. It changes the moment you mix it because of inherent reactions. So we took this turmeric, we put it 1 centimeter layer in a beaker, and we heat it from the bottom. And on top we place a thermal camera. So the way heat travels from bottom to the top, this heat signature, it reveals whether it's an original turmeric or it's adulterated turmeric. So that solution, we made it, and in fact ACM Multimedia Top A-Star conference we presented it. So it's at prototype level right now. in order to take it to the market and product, we still have some other challenges to address. How to start, how to refrigerate, and other things that has to be addressed. So these are a few things we are doing at IIT Roper. Thank you.
Thank you, Dr. Mukesh, for giving a very wonderful, very deep technical, detailed discussion. The work which we are doing at IIT Roper, and I feel very proud to see that some of the impactful work is already coming out. When you look out to the Annam, it is one of the flagship initiative by Ministry of Education coming out as Center of Excellence. We have 3 Center of Excellence in the country, and again very proud to say that IIT Roper is one of the first amongst the young generation which has been shortlisted for this program. This is an initiative of 990 crore plus. We have the first 3 which was launched in the beginning coming at IIT Kanpur and IIT Roper as 1 and 2, whereas third one is with IIT Bangalore as of now. And very recently for the education sector, IIT Madras was also shortlisted. So thank you once again for sharing out that. When I look out to this particular opportunity at India AI Impact Summit, this is a historic moment for us. While we are also hosting out this at a scale which is very commendable, we also have to look out, and we also feel the gravity in AI which is expanding beyond the traditional power block. But to translate this vibrant ecosystem and the leadership, India must now move from ecosystem building to the ecosystem thinking. And that is the 5 pillars of this ecosystem has to be worked out together, and which I feel are into compute. The first pillar which actually we need to do a lot of work, where already Government of India has enabled 38,000 plus GPUs, 18,000 are already being used by the startups, by the ecosystem. But I think we need to work a little bit more into the sovereignty side. One of the initiative, or I would say a part of group, which I currently support as an advisor, Quantum Tiger is also working out in similar framework. And that also we already have seen indigenous companies like A2E Network who have been building out GPU solution for the Indian startup ecosystem. The second pillar, I feel that where India again has to do a lot of work and is already doing coming out from the foundational model. I think all the 4 or 5 speakers have spoken a lot about and have emphasized on indigenous foundational model in the last 2 days as well from the other panelists. We already have seen the India DPI stack, be it the Basini, which is building out 22 plus language model, and very, very heavily been used out. I think you all might have visited their pavilion as well. And the other DPI stack like Aadhaar and UPIs are all wonderful example coming from the India. The third pillar which we feel that is on the strong AI standardization. Again, a topic which is debatable, but I think this is where whatever kind of policies India will build will also be helping out the 8 billion plus population from the world. The fourth and very important work is on the deep sectorial integration. Integration largely into healthcare, we have heard Dr. Neelam as well into it, whereas on the education, agriculture, manufacturing, and onto the climate resilience as well. These are the 5 key pillar focus area for particular deep sectorial integration, which India has to drive toward that side. And the 5th one is on the government norms, which has to be globally accepted, but also has to be locally grounded. When we talk about the India, we have to move from the vernacular model, whereas something which actually has been accepted in local languages and could also be adopted toward the international forum side. With that, this panel, I really feel privileged to moderate and to host you over here. If we have any questions, we can take 1 or 2 from the audience. If anyone would have any questions for our panelists, I think we do have time around that. Yeah.
Situated in Canada. Okay, so I'll ask this. Given the geographical presentation of Saskatchewan, which is like a cold desert, to be honest, right? So how do you manage those challenges, and is there any approach that you are thinking that using AI to overcome that climate change, or I would say the harsh conditions to promote the agriculture side of it, because Saskatchewan is more or less dependent on the agriculture side of it, right? So what's your thought on that?
Well, it's an excellent question. Those who came late, my name is Ajay Dalai from University of Saskatchewan, a professor in chemical and biological engineering. So when you look at the entire the Canada, it's about six months or so. It's cold, as you mentioned, and when you look at the province of Saskatchewan, as I mentioned earlier, we have 48% of arable land that the country has. and the agricultural is about agriculture activity is about 5 months in a year, and during that time they have to basically cultivate the crops and harvest it and sell it. It's mostly for marketing. It's not for internal consumption. So when you look at the climate change itself, climate change is a global phenomenon. It's not a Canadian thing. When you look at the energy consumption in the world, 80% of energy is now coming from the fossil fuel, and by 2050 we are thinking it will go down to about 70 or 65%, and 35% will be renewable energy. Canada being an agricultural hub in the entire planet, also you have 10% of world forest in Canada with 0.5% of world population. There's basically carbon sink or the CO2 sink in the summer, and in the winter it's the other way around. When there is basically colder days in Canada, we look at how people can depend less on fossil fuel and depend more on renewable energy such as bioenergy, solar energy, nuclear energy, etc. And it's a very complex situation because Canada is the only G8 country which exports energy. We have too much oil and gas. To convince people to give up those those things and adapt to renewable energy has been a challenge. But the government has a right approach. It's the right policy, provincial, federal. They're very aggressive. They want to net CO2 zero by 2050. So I think through AI model with implementation of renewable energy, we can get away from the lot of CO2 emission and use the renewable energy for the winter months, for example, rather than relying on the fossil fuel. As you know that the people can live cannot live without energy in Canada because it's so cold. Like when I left in the last week of January, it was -50 in my city. So you need to use a lot of energy, and how we can integrate the renewable sector with the fossil fuel so that we have less impact on the climate and people also have a good quality of living. So I think it's a complex issue, and as I mentioned, we are still learning how to integrate AI into good quality of life and use less fossil fuel, increase the renewable energy mix. And as I mentioned, our province also has 30% of world uranium. So how we can use uranium to build the nuclear power plants within the province, within the country, so that we rely less on the fossil fuel. So I think that those are the things that we are working on, and we want to learn a lot from India. India is quite advanced in AI compared to what we have. And we have Steve, who's not here. He works on sustainable agriculture. Baljit Singh, who's our vice president, works on the health side. One Health. Just about my own research, just wanted to maybe take 2 minutes or a minute or so. So when you look at the fossil fuel generation from the organic material, so with the heat and pressure, we get this oil, gas, and coal over millions of years. So what we are trying to do is take the organic residue from the agriculture, from the forest, from municipal solid waste, and use the heat and pressure, and within 1 hour, convert it to oil, gas, and char. So it's basically similar to what we have from the fossil fuel, and make it more accessible, more renewable, similar products. And when you look at the aviation industry, it consumes about, it emits about 2% of world's carbon dioxide. And what we can do from the biomass to produce the aviation turbine fuel, so that we have a less impact on the environment through aviation sector. And because we have a lot of biomass, not only in India and Canada, but everywhere in the world, can we use those more wisely through AI application, so that we can get a better product and be kind to our next generation of people without suffering from the climate change. And we want to
leave the world as we have inherited. We don't want to pollute and leave, and it's a big issue for our next generation. So I think AI has a lot to do with it. Very complex integration between agriculture and also the residue, the energy sector, the farming activities. So I think that a lot of integration can be done and for the benefit of the society. Thank you.
Thank you, Dr. Ajay, for a very detailed answer. We'll have very quick short question, and also if the speaker could put it on the same way.
This is a question for Dr. Professor Manisha, right? So we are known for Namatapuri, like a lot of our central theme is creating social impact and giving back and social impact, creating social impact in whatever we do. How do you see the technology, like emerging technologies like AI and other things, helping our central theme, giving back and creating social impact, ma'am?
So, based on our experience, one of the major thing which we are seeing is like, wherever we work in the society, the most important factor is bringing in empowerment. These technologies are helping us naturally to fast track the empowerment. And based on that, when we work with them, it has to go hand in hand with the capacity development, and at the same time ensuring that values are not degrading. Both hand in hand you have to work and then build a solution. So that is where we are looking into it. Rather than giving a result, it should be naturally giving an outcome which will help them to select what they want actually. Otherwise we will do the wrong things actually, because we comes from urban side and we think what we think is right. That may not be the right thing with respect to the ecosystem they are there, because they are the people all along has been supporting the whole urban system in the country itself. So they have much bigger knowledge than us. That's the first thing. If we know that, we have to train our AI to learn that, because what current AI has is more or less the urban knowledge, not the real fundamental knowledge which the farmer in this country knows actually. They know how to be resilient. They know how to handle the weather. How do we learn from them is what we have to bring. So our tools, whatever we develop, should be able to capture that. And that should be brought out to the world, so that, because that's one of the major challenge which you see in the AI with the bias actually. So that has to be taken care of in this whole process.
Thank you, Dr. Manisha, for giving very detailed answer. As well as if you look out to AI and to the agriculture, to the healthcare, these are the sectors where we cannot have where we need to have an accuracy of almost 100%. Just yesterday when we were hosting a program with Israel Embassy, we had a same thought process, where even if you have 90% accuracy, we cannot say that. It has to go into the field. And that's where for the agriculture specifically, technology has to be 100% accurate. If it fail even by 1%, we are talking about one crop cycle, we are talking about one entire human race to get, challenges there. With that, this is one of the very deep technical session that I have moderated for the very first time. And I hope that you all have got key insight around that. From India and from the Canada, we look forward to having a lot of collaboration with among the universities, with among the researchers, and also with the startup community there. Thank you so much. Thank you once again. If we could have a group photo also after this.
Sure. Thank you so much to all the panelists for such a wonderful discussion. And thank you so much for being here. Thank you. We'll just have one more picture, sir. Click right now. Thank you.